Lab 2, Charged Tapes. Introduction. So in this lab, we discuss the idea of excess charge and electric forces. However, we do so with an updated model, in where we treat the tapes not as a single point charge, but rather as multiple. The fundamental physical principles are Coulomb's law, which is the electric force is equal to 1 over 4 pi epsilon naught times Q1 times Q2 over R squared. And then we have the gravitational force, which is just equal to mg. And then Newton's second law, which states that for every action, there's an equal and opposite reaction. So in this case, we know that the force of gravity has to be equal to the electric force of the tapes, which causes the tape to float. Once we performed the experiment, we saw how the two charged U-tapes would repel each other, which led us to conclude that they have the same charge, and how the U-tape was attracted to neutral objects such as hands, books, and then we also saw how the tape, because they have the same charge, they repel, which causes the figure to the right, and causes tape B to end up floating above tape A. Data. So we know that the force of gravity is just going to be equal to mg, which is 1.96 times 10 to the negative 3 newtons. The separation distance at which the tape begins to float is just a measurement, which is 0.01 meters. And then the charge on tape B, we know that the force of gravity has to be equal to the electric force. So here on the right, there's a diagram where we have tape B, and then the force electric up, and then the force of gravity, and they're equal in magnitude. So we use the equations here, and we can solve for Q, which is equal to 4.667 times 10 to the negative 9 coulombs. So we also get the excess electrons, and we do that by dividing the charge we just calculated by the charge of an electron. And then we get the number of atoms by dividing the length of the tape by the size of an atom. And then we can get the ratio of electron to atoms just by dividing the number of electrons by the number of atoms. And then at the end, we can calculate the force, which is just plugging in the numbers and the charge we got, and it's the same as a gravitational force. The main assumption is that the tapes both have the same amount of charge and that the charge is evenly distributed along the length of it. However, previously we had used the idea of the point charge approximation, in which we modeled each tape as having the charge located at the center of it. However, for this lab, we just used a line charge. Coding. For this section, I downloaded first the starter code, and with that, I used QOLD, which was 4.667 times 10 to the negative 9 coulombs, which is what I just previously calculated in lab number 1. And then for this second lab, the magnitude of the charge on one piece of tape after some trial and error was Q nu, which is 4.954 times 10 to the negative 9 coulombs. So I downloaded the glow script, and then we have first the physical constants, and then the observed values, such as the mass of the tape, then Q, and then the number of charges we're going to use to represent it. Then I have the E-field function, which I just got from lab 0, and it's the same. And then there's a function that's going to create line charges for both of our tapes. Here I have tape A and then tape B, which is just the top tape and the bottom tape. And then here we have the charges in top tape, and these are going to be the green arrows that we see at the end of the code. And then I created the magnitude of the electric force by calling the arrows we have previously created. And this is what comes out of our glow script. And it's the bottom tape and the top tape, and then I have the electric force and the gravitational and each force that comes from each charge, and then we printed out the magnitudes. So the first question, if we model each tape as a single point charge, the results wouldn't be as accurate as they are right now, because the point charge model gives us a Q of 4.667 times 10 to the negative 9 coulombs, and the line charge model gives us a Q nu of 4.954 times 10 to the negative 9 coulombs. However, these estimated values are not that different from each other, and they result from having more charges model the line charge rather than just having a single point charge. So these models and the estimates actually are different because we're using different models. the point charge is kind of more of an estimate compared to the line charge model, because the line charge model ends up being more accurate as it is not as simplistic and allows us to distribute the charge throughout the tape, having more point charges represent the tape rather than just using one.